linear pair axioms. These are two axioms, and that's why they are called linear pair axioms. Before we understand the axioms, let us understand intersecting and non-intersecting lines. If somebody asks you to draw two different lines, PQ and RS, on a paper, how many ways are there in which you can draw them? There are two ways to draw two lines. Either they could be intersecting as in the first option, or it could be non-intersecting as in the second option. We can draw them in two different ways. Either they could be intersecting lines or they could be non-intersecting lines. Lines PQ and RS in the first figure are called intersecting lines, and in the second figure they are called parallel lines or non-intersecting lines. Note that the length of the common perpendiculars at different points on these parallel line is the same. So if I have to draw a perpendicular line here, and I have drawn 1, 2, 3, 4, 5 perpendicular lines, they are saying that the length of common perpendiculars at different points, they are drawn at different points, are going to be same. Because these two lines are parallel, the perpendiculars drawn, all the perpendiculars drawn will have equal length. And this equal length is called the distance between the two parallel lines. Now let us find out the relationship between angles formed when a ray stands on a line. So as you can see, OC is a ray which is standing on line AB. What are the angles formed at point O? There are three angles formed. They are angle AOC, angle BOC, and angle AOB. Can we write angle AOC, so you can see it in orange color, plus angle BOC, which is in purple color. If I add these two angles, do I get angle AOB, which is the straight angle? So that means, do I get the whole angle if I add those two different angles? Yes. Why? So we have learned that when two angles are adjacent, then their sum is equal to the angle formed by the non-common arms. And you can see the angle formed by the non-common arms, which is arm OA and OB, is the straight angle. So angle AOC plus BOC is equal to angle AOB. What is the measure of angle AOB? It is 180 degree. And why? Since the non-common arms form a straight line, so you can see OA and OB form a straight line, the angles formed is equal to 180 degree. A straight angle is 180 degree. So if angle AOC plus BOC is equal to angle AOB, let us take it as statement 1, and angle AOB is also equal to 180 degree, let us take that as statement 2, then from 1 and 2, what can we say? This plus this is equal to AOB, and AOB is equal to 180 degree. So we can say, can we say, it's a question, can we say that AOC plus BOC is equal to 180 degree? Yes, we can, because according to the axiom 1 of Euclid, things that are equal to the same things are equal to one another. And so we can say that AOC and BOC are equal to 180 degree. This statement has been taken as and written as an axiom which does not need proof. So we will accept it that if a ray stands on a line, a straight line, then the sum of two adjacent angles so formed will be 180 degree. Okay? Recall that when the sum of two adjacent angles is 180 degree, we call them linear pair of angles also. Here, the given statement is a ray stands on a line. If you look at the statement of the axiom, if a ray stands on a line, that means we have to draw a ray which is standing on a line. So that's a given statement. Then this is called the concluding statement. Then the sum of two angles formed is 180 degree. So that's the result of the statement, of the previous statement. If this is true, then this is the conclusion. So if a ray stands on a line is a given statement and the sum of two angles so formed is a concluded statement. Can we write the other way? So that is, take the conclusion as given and given as conclusion, and so it becomes, if the sum of two adjacent angles is 180 degree, then the ray stands on a line. That means the non-common arms from a straight line. That means the ray, which is the common arm, is standing on a straight line. So we have just flipped this. Now, is this statement true, which is called statement A here? Is that true? If the sum of two adjacent angles is 180, then the ray stands on a line. Now, if you see that axiom 6.1 and statement A are in this sense reverse of each other, we call that converse of the other. The mathematical word of reverse is converse. We do not know whether statement A is true or not. Let us check. So we draw different adjacent angles of different measures. Keep the ruler along one of the non-common arms in each case. So if I put a ruler here, okay, I get OB on the ruler, keep OB on the ruler, OA will not be on the ruler. The addition of two angles is 90 degree. I don't get a straight line. The ray, the common arm, the ray, which is OC, is not standing on a straight line in this case. In this case, 60 plus 80 is 140. And if I have kept a ruler here on AB, OB, OA will not be on the ruler, right? It will not lie on the ruler. So the ray is not standing on a line. In the fourth one, if I keep a ruler on OB, and we see the two adjacent angles are 150 plus 70 degree, that will be 220 degree. Again, OA is not going to be on that ruler, and so the ray is not standing on the line. But consider this option figure number 3. Here 125 degree plus 55 degree gives you 180 degree, and if you are putting a ruler, you will get OB and OA on the ruler, so you get a straight line. And only in this case I can say that the ray is standing on the line. So consider this statement A. If the sum of two adjacent angles is 180 degree, then the ray stands on a line. Isn't that true? Only when the sum was 180 degree, I can say that OCE, which is the ray, is standing on line AB. So that's a true statement. So you will find that both non-common arms lie on the ruler in this case, and OB lie on the same line. Point A, O, and B are on the same line, and ray OC stands on it. So ray OC is standing on the line. Also, the addition of the two angles is 180 degree. And so if the sum of two adjacent angles is 180 degree, then the non-common arms of the angles form a line, is taken as axiom 6.2. because it's correct. if the two angles form 180°, then the non-common arms, which is OA and OB, will form a line. From this, we may conclude that statement A is true. And so you can state it in the form of an axiom. So the first axiom we learned is axiom 6.1. If a ray stands on a line, then the sum of two adjacent angles so formed is 180°. And the converse of axiom 6.1 is axiom 6.2, which is if the sum of two adjacent angles is 180°, then the non-common arms of the angles form a line. Okay? For obvious reasons, these two axioms above together is called the linear pair axiom. The obvious reason is in both of these axioms, we are considering linear pair of angles, and therefore they are called linear pair axiom.